Hello everyone, so today I'm going to do Vcaa 2016 Methods Exam 1. So let's get started without further ado. Okay, so question number 1, so we have y equals to our function over here, and now what we are asked to do is to differentiate. Okay, so we can just simply use quotient rule for this question over here. So let's say dy over dx is just going to be keep the bottom one as it is, so x squared plus 2, multiply it and differentiate the top one, so that will be negative sine of x, minus, now we differentiate the bottom one, so 2x, and then multiply it by the top function, so cosine of x. Alright, and of course divide the whole thing by the bottom function squared, so x squared plus 2 whole squared. Now this will simplify our answer to negative sine of x times x squared plus 2 minus 2x cosine of x all over x squared plus 2 whole squared. Now I'll be trying to give out suggested marking scheme. I'm not saying I know that this is going to be a mark for sure, but just a suggested marking scheme. So yeah, so in this question it's going to be 1 here and 1 here. That's your 2 marks. So this is just a suggested marking scheme. Again, do not quote me for this. Alright, so now we have another function over here, and what we have to do is to evaluate f dash of 1. So let's find the derivative of this function first. So how do we do that? Well, f dash of x is going to be equal to, now differentiate x squared term, we're just applying the product rule here, so differentiate the x squared term, we get 2x. Now keep e to the power of 5x the same, no change. Now plus, now keep x squared the same and differentiate e to the power of 5x, so it's going to be 5 e to the power of 5x. So our derivative is going to equal 2x e to the power of 5x plus 5x squared e to the power of 5x. And now f dash of 1 is just going to be 2 e to the power of 5 plus 5 e to the power of 5, which is going to be equal to 7 e to the power of 5. So our f dash of 1 is equal to 7 e to the power of 5. Now again, our suggested mark here is going to be 1 here and 1 here, so that's your 2 marks. So moving on to question number 2. So we are given this function again, and what we have to do, we have to find the derivative function. Well, first thing, we can also see that we can write f of x as 1 minus 2x to the power of half, right? And now f dash of x is just going to be, so bring the power down, times it by the whole thing, so 1 minus 2x. Now subtract the power by 1, so it will be negative a half, times it by the differentiation over here, or of the inside function. So if we differentiate 1 minus 2x, we will get minus 2. And that will simplify to negative 1 on square root of 1 minus 2x. So our answer is just going to be f dash of x equals to negative 1 on 1 minus 2x. Now this is going to be our 1 mark over here. Okay. Find the angle theta from the positive direction of the x-axis to the tangent to the graph of f at x equal to minus 1, measured in anti-clockwise direction. Okay, so first let me just draw the graph of this real quick, because it's quite easy for me to visualize when I draw the graph. And take this tip, when you cannot do anything in methods, try and graph it out. It will make a lot of sense, and it will make it a lot easier for you to do. So yeah, so this is going to be half, and again this is just going to be our tangent. So if I were to draw a tangent over here like so, okay, now this is going to be negative 1. And now what we have to do is to find the angle theta measured from the positive direction of the x-axis in anti-clockwise direction. So anti-clockwise direction is this way, and we are measuring it from the positive direction of the x-axis. So this is going to be our theta. Alright, so let's just solve for the gradient first, because gradient is also equals to tan theta, right? And then we can just figure out what the theta is. So f dash of negative 1 is going to be negative 1 over 1 plus 2 which is just going to be equal to -1 on square root of 3. So tan theta, which is also equal to gradient, is going to be -1 on root 3. Now gradient of this line over here, okay? So now here we can determine the theta now. So if I were to show you how to calculate this, so let me just draw the unit circle real quick. So now we can see that we have to calculate tangent equals to -1 on root 3. Now, which quadrant is tangent negative? Second and fourth. Right, so this is going to be our theta here, and this is going to be our theta. Now, which theta to pick? So one theta, so one of the values of the theta, one of the values of the solution for this is going to be -pi on 6, and the other one is going to be 5 pi on 6. Now, to represent these values on the diagram or the graph we have got here, this angle over here is going to be -pi on 6. So therefore, this angle over here is going to be theta, meaning our answer is going to be 5 pi on 6. So that's how you do this question. Alright, now let us move on to question number 3. So we have this function over here, and what we have to do here is to sketch the graph of f. Oh, sorry, I forgot to show you my suggested marking scheme. So one mark for this and one mark for picking the correct answer. Alright, so now we have to sketch this graph, label the axial intercept and also the asymptote. Okay, so our function is going to be this. So we can clearly see that one of our asymptote is going to be x equal to 1. The reason being that if I were to make x equals to 1 and substitute x as 1 in this function, we will get 3 over 0, and which is just going to make the function undefined. So vertical asymptote is just going to be x equal to 1. So let's just make a dotted line. Now I'm drawing this without ruler, but make sure you do it with pencil and a ruler. Okay, so that's that. Now the other horizontal asymptote is going to be y equals to 2, right over there. So we can draw that out real quick. So y equals to 2. Now next thing we could do to make our life easier and decide the shape of the graph is solve for the axial intercepts, of course. So let's do that now. So y-intercept is when x is 0, so f of 0, that would just be 2 minus 3, which is going to be -1. So our y-intercept is going to be negative. So y-intercept is just going to be 0, -1. Now x-intercept is when f of x equal to 0. So 2 plus 3 on x minus 1 equals to 0. And now this would imply that 2 equals to -3 on x minus 1, which would give us -3 equals to 2x minus 2, and therefore x is going to be equal to -1/2. So our x-intercept here is going to be -1/2 and 0. So let's label them real quick. So -1, 0, -1, and -1/2, 0. Now we have the axial intercept, now we have the asymptote. So now we can easily plot the graph. So let's do that. And no, this is wrong. Okay, this is what the graph should somewhat look like. Now make sure you have proper shape of graph, because there is also, I think, 1 mark allocated to it. I'm not sure, but I think they do check the graph quite strictly. So any mistakes like, just doing like that at the very end, like moving away from the asymptote, is going to be considered as incorrect. So make sure you graph properly. Okay, now that's one component done. Now because this is a hyperbola, so this will have another component over here like that. Now for this, sometimes they are very tricky with this, in a sense that if I were to just draw this graph blindly, I would draw something like this. Now the thing is, what if this graph is not to scale? Like if I were to substitute 2 in. Now let's keep the graph like this. Now let's substitute f of 2, like this value over here. Now let's substitute that in function over here, right? So we'll get 2 plus 3, which is going to be 5. So 2, 5. Our graph is meant to be passing from this point over here. But is it doing so? No. So that's how they cut your other mark. So make sure you do not fall for this trick. So make sure you just substitute in one other point just to get the scale of your graph right. Alright, so now we can just graph this, so it's going to be like that, roughly like this, and it's going to be like that. Alright, now okay, you cannot do this technically in the exam, but yeah, you have to make it one straight smooth line, which is quite hard. I struggle with it myself. Anyway, yeah, so this is your answer. So again, 3 marks. Well, 1 mark for this x and y intercept, correct? X and y intercept. 1 mark for labeling asymptote, and 1 mark for just the shape of the graph in general. So those should be, I think, your suggested 3 marks over here. Alright, now part B is asking us to find the area enclosed by graph F, the line x equal to 2 and x equals to 4 and the x-axis. Okay, so to graphically represent this, we are finding the area between these two parts. So highlighted section just between these two parts over here. So this is the area that we are finding. Okay, now how do we find area under the graph? Well, just integrate. So we have to do integration from 2 to 4 of 2 plus 3 on x minus 1 dx, which is going to be 2x plus 3 log base e of mod x minus 1. And of course, don't forget the terminals, so 2 and 4. I've just integrated this entire function, so 2, if we integrate 2, it will become 2x, and if I were to integrate 3 on x minus 1, it will become 3 log base e of modulus x minus 1. Now this would be the same as writing 2x plus 3 log base e x minus 1. Now in methods, you can just take out modulus as positive, it's fine, but in specialist maths, you have to be very careful about it. I'm not going to go into too much detail because it's just methods, but just a heads up. Alright. So again, not forgetting our terminals, so 2 and 4. Now we'll just substitute the terminals in, so 2 times 4 plus 3 log base e 4 minus 1 minus 2 times 2 plus 3 log base e of 2 minus 1. So this will become 8 plus 3 log base e3 minus 4. So our final answer is just going to be 4 plus 3 log base e of 3. So that's how you do this question. Hopefully it made sense. Now let's move on to question number 4. Okay, so our paddock contains 10 tagged sheep and 20 untagged sheep. So total amount of sheep is going to be 30. 4 times each day. Important figure. 1 sheep is selected at random from the paddock, placed in observation area, studied, and then returned to the paddock. Return to the paddock is also very important. If it wasn't returned to the paddock, it's just basically with and without replacement. So if it's returned to the paddock, the number of sheep in the area doesn't change, but let's say if I were to take it from observation and not put it back in, then the number of sheep is going to change, and we have to take into account that as well. So in this case we don't, so it's all good. So what is our probability that the number of tagged sheep selected on a given day is 0? So it looks like they haven't defined their random variable here, so let's just do that first. So let x be the number of tagged sheep selected on a given day. So x is binomial. Now number of trials is just going to be 4. Probability of success is just going to be probability of getting a tagged sheep, which is just going to be 10 on 30, which is just going to be 1 on 3, right? So probability is just going to be 1 on 3. So probability of x equals to 0 is just going to be 2 on 3 to the power of 4. Now 4 because it's picked 4 times a day, and this would simplify to 16 on 81. So 1 mark just for the answer. Oh yeah, I forgot to do the marking scheme for this. So 1 mark for correctly integrating and 1 mark for the correct answer. That's what I think it should be, but yeah, alright. What is the probability that at least 1 tagged sheep is selected on a given day? Now, they want us to find probability that at least 1 tagged sheep is selected every day. which is equivalent to writing 1 minus probability of x is equal to 0. Right. So we already found probability of x is equal to 0. So 1 minus 16 over 81, which is going to be 81 minus 16 over 81, which will give us 65 on 81. So 1 mark again, just for the correct answer. What is the probability that no tag sheep are selected for? What is the probability that no tag sheep are selected on each of 6 consecutive days? Express your answer in the form of A on B to everything to the power of C. Okay, what is the probability that there are no tag sheep selected in one day? It is something that we already calculated before, right? It's right over here. We already calculated that. Now for 6 consecutive days, we just have to raise this probability to the power of 6, and that's going to solve the question. So 16 on 81 to the power of 6. Now, I generally do this just to be very safe. I just write the value. So A is equal to 16, B is equal to 81, and C is equal to 6. I generally just write it out to be very safe. I don't know if they, mark you based on this as well, but I just do it as a practice of mine. Always to be safe than sorry. So 1 mark, yep, just for the answer. So let's move on to question number 5. Now, we are given f of x and g of x here, and with their respective domains, of course, so right here and right here. And now what we have to do is to find the rule for h, where h of x is just going to be f of g of x. So h of x is equals to f of x squared plus 1, which is going to be equals to, so h of x is going to equal to log base e x squared plus 1. So that's our question done. So 1 mark for this. State the domain and range of h. Okay, so domain of f of g of x is equals to domain of g, which is equals to r, because the domain of g is just given to be r. So yeah, and now the range. Now how do I find the range of this? Well, I'm going to show that to you using a machine analogy. So let's say we have 2 machines over here. One is x squared plus 1, and the other one is just going to be f of x, which is going to be log base e of x. Okay? Now, what I'm going to do is, I'm going to take this domain of f of g of x, I'm going to take the domain of g essentially, input that in g, and that will give me a range of, what is our range here? 1 to infinity, right? Okay, now I'm going to input that range in function f of x. So that will give us an answer of 0 to infinity, which is going to be the range of this whole function. Okay, let me explain this real quick again. So I use this domain of g over here, I input that in domain of g, and then I get a range of the inside function. Now the reason why I get the range of the inside function, which is g of x, is because once I know the range of g of x, then I can look at the bigger picture of f, because g is inside f, so g must work for f to work. Right. So once I know the range of g, I'm going to use the range of g. Now I'm going to input the range of g in f of x to find the range of f of g of x. And that's how I got the answer 0 to infinity. So our domain is going to be r, and range is equals to 0 to infinity. I hope that made sense. So again, 2 marks, 1 for this and 1 for that. Alright. Now show that h of x plus h of minus x is going to be that. So we already know h of x is just going to be log base e of x squared plus 1. Now h of negative x is going to be log base e. Now substitute negative x into x squared, it's just going to give us x squared again, plus 1. And now let's solve for f of g of x squared, which is equals to f of x squared plus 1 whole squared, which is going to be log of base e x squared plus 1 to the power of 2. Now I'm going to bring the 2 down over here, log laws, so that would just be 2 log base e x squared plus 1. So that's your f of g of x squared. Now let's add h of x and h of negative x. Now you can see they both are the same function, so h of x plus h of minus x is just going to be 2 times log base e of x squared plus 1. Now we can see it's just going to be the same thing, so hence LHS is equals to RHS. So 2 marks, 1 for this and 1 for that. There you go, that's your 2 marks done. Now find the coordinates of stationary point of h and state its nature. Now this is 2 mark over here, so we can easily be able to tell, and 1 mark is for the correct stationary point, and the other mark is going to be stating the correct nature of the stationary point. Now, to find the stationary point of h or any other function, what do we do first? We will differentiate the function and then set it equals to 0. So let's start by differentiating the function. So h of x would just be 2x over x squared plus 1. Now you must be wondering, how did I do it so quickly? Well, I have a trick to show you. So whenever you have a function like this, so log base e of f of x, to differentiate, the answer will always be differentiate the f of x and divide it by f of x. That will always be the answer for log base e of f of x. Now as the base changes, this is not going to work. If you try it for log base 2, not going to work. This formula only works for log base e, and that's how I got the answer so quickly. Now if you want to see the proof of this, I'll add the link down in the description below so that you can have a look. Anyway, getting back to the question, so now h of x is equals to 0. That's how we solve for stationary point. So 2x divided by x squared plus 1 equals to 0, meaning that 2x equals to 0, therefore x is equal to 0. Now we have the x coordinate of the stationary point. To find the y coordinate, what do? Just substitute back in, so h of 0 is going to mean log base e of 0 plus 1, which is just going to be 1, which is equal to 0. So stationary point is equals to 0, 0. Now to solve for the nature of this stationary point, what I'm going to do, well, I'm just going to use our trusted table method. So x, h dash of x, and slope. So now what I'm going to do, I'm going to pick -1, 0, and 1. Because we know that there's going to be stationary point at x equals to 0, I'm just checking out whether the gradient is positive or negative on either side of the stationary point, and that way we can easily determine the nature. So -1, 0, 1. So here we can already tell that h dash of x when x equals to 0 is just going to be 0, because, well, the gradient at x equals to 0, we already calculated that is going to be a stationary point, and hence it's going to be 0, so there is no gradient. Now what happens at x equals to -1? If I were to substitute x equal to -1 in h dash of x, it's going to give us -2 on 2, which is just going to equal -1. So our slope is going to be like so, negative slope. And if I were to substitute 1 in h dash of x, it will give us 2 on 2, which is again just going to be positive slope. So now we can easily see that it's going to be a minimum point, right? So it's going to be shaped like this, so it's a minimum point. So yeah, and so our answer is just going to be hence a minimum point. Sorry, I spelled this wrong. Minimum point. Okay, so our 2 marks again, 1 mark here and 1 mark here, just the suggested marking scheme. So yeah, all right, let k be this function over here, which is exactly the same as h of x, except they have specified a domain. Now what we have to do, find the rule of k inverse. So first line I'm going to write is let y equals to k of x, which is equals to log base e x squared plus 1. Now why did I write this line? I'm going to explain later. Now the next line I'm going to write, now whenever we have to calculate inverse, you must always write this line, which is swap x and y for inverse. You must always write this line, no matter what, whenever you are solving for inverse. No matter if it's exam 1 or exam 2, try to write it in both of them. Now we can easily say that x is just going to be equals to log base e y square plus 1. Now that's why I wrote let y equals to kx equals to that. The reason being that I'm going to use y later in my working out, so I just clarified what y is. It makes things easier for me. It also makes, clear sense to the marker that y is going to be k of x instead of just, inputting y everywhere. So yeah, make sure you go for a systematic approach. That way it's easier for both parties. Okay, so e to the power of x equals to y square plus 1. So e to the power of x minus 1 equals to y square, meaning y can be positive or negative square root of e to the power of x minus 1. Okay, now let's see if we have to reject any of this. We probably have to, the reason being that they have specified the domain here. So meaning that there'll be only one answer which satisfies the inverse for this rule over here. How do we find that? Well, we know the property that domain of k of x is equals to range of k inverse of x, right? Which is equals to what? Negative infinity to 0. Sorry, inclusive. So now what we have to think about is we know the range of k inverse. So we have to find out whether this function will have a range of negative infinity to 0, or would it be this function to have the range of negative infinity to 0? It can't be both, or maybe it can be, who knows, we'll find out. So how do we test this? Now, let's look at this question, let's look at these two equations carefully. So if I were to look at this part, ex e to the power of x minus 1, now this part always must be positive or 0. It cannot be negative. The reason being that square root of negative number does not exist. I mean, not in methods anyway, especially if it does. It kind of gets exotic. But for methods, you don't have to worry about it. Whenever you see a negative square root, like a negative number under a square root, it's just going to be straight up undefined. So we cannot have e to the power of x minus 1 as negative. Now, if that cannot be negative, the whole answer is just going to be positive, right? Because square root of a positive number is just going to be positive. So there is no way the range of that function is just going to be, negative infinity to 0, because that has negative numbers as well. And we want negative numbers. So it is safe to say that we have to reject this function. The reason being that this will only input the range from 0 to positive infinity, and which we don't want. We want a function with range of negative infinity to 0, which is the range of this function over here. And that's why we have to write our solution as k inverse of x is equals to negative square root of e to the power of x minus 1. I hope that made sense. So 2 marks, 1 mark for maybe finding this, and the other mark for rejecting the other one. So I think that should be the 2 marks over here. Okay, now state the domain and range of k inverse. So range of k inverse of x is equals to domain of k of x, which is going to be equals to negative infinity to 0. It is already given in the question, so yeah, that shouldn't be a problem. Now the domain of k inverse, so domain of k inverse of x is going to be what? How do I calculate that? We know that k inverse of x is going to be what? K of x, k inverse of x is going to be negative e to the power of x minus 1. Now again, as I mentioned previously, that e to the power of x minus 1 has to be positive or 0. It cannot be negative or things get a bit weird. So yeah. So now we just have to solve for this inequality and make x the subject to get our domain. So let's do that. So e to the power of x is greater than or equal to 1. So x is greater than or equal to log base e of 1, and log base e of 1 is just going to be 0. So our domain is just going to be 0 to infinity, and there you go. So 2 marks, 1 over here and 1 over here. Alright, let's move on. Question number 6. So we are given this trigonometric function here, and what we have to do is to calculate the average rate of change between these two points. So average rate of change has a formula. So average rate of change equals to f of negative pi on 3 minus f of pi on 6 divided by minus pi on 3 minus pi on 6. It's just like basically calculating the gradient. So what is the formula for gradient? It's just going to be y2 minus y1 over x2 minus x1. Yeah, same thing. It's the exact same formula. So let's calculate f of negative pi on 3, which is going to be 2 times negative square root of 3 on 2 minus 1. Now how did I get this negative root 3 on 2? Well, I got it by solving sine of negative 2 pi on 3. Now this is the same as writing sine of negative pi plus pi on 3. Now let me just draw a unit circle to show you where this point lies. So negative pi, we go from here to here, and then plus pi on 3. So this angle over here, where theta is just going to be pi on 3. So what we are doing is we are essentially solving for sine of pi on 3, which is going to be root 3 on 2. Now why is there a negative? Because sine is only positive in first and second quadrants. So therefore, we put a negative sign, and that's how I got it. Alright, I hope that made sense. Okay, so let's move on with the question now. So this will simplify to negative root 3 minus 1. And f of pi on 6 is going to be 2 times square root of 3 on 2 minus 1, which is equals to square root of 3 minus 1. Alright, so now we just plug all of the values in the formula. So average rate of change equals to negative root 3 minus 1 minus, always at brackets just to avoid mistake in sign, because sometimes you forget to change negative, negative, positive, so it's always better to write brackets, divided by negative pi on 2. And now solving for that would give us negative 2 root 3 on negative pi on 2, and which would mean that our average rate is going to be 4 root 3 on pi. So there you go, that's how you do this. Now 1 mark for maybe the correct working out, it's because it's a 2-mark question, and 1 mark for the correct answer. Okay, calculate the average value of f over the interval of that. Okay, so average value has a formula. For those of you who forgot, that 1 on b minus a, integral from a to b f of x dx. So this is the average value formula, and we can just use that to calculate the average value here. So our average value is going to be 1 on pi on 6 minus pi on 3. So that is just going to become plus pi on 3 integral from negative pi on 3 to pi on 6 to sine 2x minus 1 dx. Okay, now let's solve for this integral over here. So this would just become 1 on pi on 2, and integrating this we will get 2 times negative 1 on 2 times cosine of 2x minus x. Now I got straight to integration because integration of sine and cosine and differentiation of both of them is given in the formula sheet already, so you can just get it from there. However, it is good that you keep them on top of their mind so that you don't have to flicker through formula sheet as much and waste your time, because it's already quite a short time to finish the exam. But yeah, alright, so minus pi on 3 to pi on 6, that would give us 2 on pi negative cosine of 2x minus x, so negative pi on 3 on pi on 6. Now just substituting our terminals in, so 2 over pi minus cosine of 2 times pi on 6, which is just going to be pi on 3 minus pi on 6, take away minus cosine of minus 2 pi on 3 minus pi on 3 and close bracket. So we just solve for that to get our answer. So simplifying this, so 2 on pi and this would become negative half minus pi on 6 minus 1 on 2 minus pi on 3, which is equals to 2 on pi negative 1 on 2 minus pi on 6 minus 1 on 2 plus pi on 3. And this would give us 2 over pi minus 1 minus pi on 2, and this would give us negative 2 on pi minus 1. So that's your answer. Now 3 marks, 1 mark for maybe this over here, the second mark for correctly solving the integral, and third mark for the correct answer. This is my suggested marking scheme. Alright, question number 7. So a company produces motors for refrigerator. There are 2 assembly lines, line A and line B. 5% of motors assembled on line A are faulty, and 8% are on line B, which are faulty. So in 1 hour, 40 motors are coming from line A and 50 are coming from line B. At the end of an hour, 1 motor is selected at random. All motors have been produced during that hour. What is the probability that selected motor is faulty? Express your answer in the form of 1 on B, where B is a positive integer. So let's now first find the amount of motors that are faulty from line A. So faulty from line A, which is just going to be 5%, so 0.05 times 40, because that's how many motors are coming from line A in 1 hour. This will give us 2. And faulty from line B is going to give us 0.08 times 50, which is going to equals to 4. So the total amount of faulty motors produced, so total faulty motors produced is going to be 6. And how many motors are made in 1 hour, like total amount of motors? So total motors made in 1 hour is going to be 90. 50 from line B and 40 from line A. So probability of it being faulty is going to be 6 on 90, which is going to reduce down to 1 on 15. So B is going to be 15. So 1 mark for the correct working out and 1 mark for the answer. That's your 2 marks over here. Now the selected motor is found to be faulty, so just straight up given, and it implies that this is a conditional probability question because it's already given that motor is found to be faulty. What is the probability that it was assembled on line A? Express your answer in form of 1 on C, where C is a positive integer. So what we are essentially finding is probability of it being from line A given that it was faulty. That's what we are solving for. Alright, this is a conditional probability question, so this will just be probability of coming from line A intersecting faulty divided by probability of faulty. For this question, I'm just going to quickly draw a tree diagram over here. So line A, line B, so A and B. What is the probability that it comes from line A? It's just going to be 40 over 90, which is going to be 4 on 9. So this will be 5 on 9, of course. So faulty and not faulty. Now what is the probability that it is faulty and coming from line A? So it is going to be 2 over 40, which is just going to reduce to 1 on 20. And not faulty is going to be thereby 19 on 20. Now B, so faulty and not faulty. What is the probability that it is faulty? Well, it's just going to be 4 over 50, so that is going to reduce to 2 on 25. So this is going to be 23 on 25. So now this part over here, intersection of it coming from line A and faulty, is saying that we have to look at this branch over here. So that is basically the main part done and dusted. So now this is just saying that 4 over 9 times 1 on 20, divide the whole thing by probability of it being faulty, which we already calculated to be 1 on 15 in the previous question. And now this will become, so 4 and 5, so this is just going to be 1 on 45 divided by 1 on 15, which is going to be 1 on 45 times 15, which is going to be 1 on 3. So that's our answer. Now 1 mark is just for correct answer over here. Alright. Question number 8, last question of this exam. So we are given this probability density function over here. We are also given a graph of it, and we are given that it has a turning point at x equals to 1 on e. So pretty good. So show by differentiation that x to the power of k over k squared times this whole thing is the antiderivative of that, where k is a positive number. So what we are basically trying to do is we have to differentiate x to the power of k over k squared times k log base e of x minus 1, and show that when we differentiate it, it equals to that. That's all this question is asking us to do. So again, we can apply, and we have to apply product rule to do this question. So what I'm going to do is I'm going to differentiate this term over here first. So kx to the power of k minus 1 over k squared. Keep the second term, the whole term, as it is. So k log base e of x minus 1. Plus, now keep the first term as it is, so x to the power of k over k squared. Now differentiate the second term, which is just going to be k over x. Because k is a constant, so we can't differentiate that. So we just have to differentiate log base ex, which is just going to be 1 on x. And differentiating 1 will just result in 0. Alright, now we can cancel out a few things. So this k and this k can cancel out. This k and this k can cancel out. So let's rewrite this properly. So x to the power of k minus 1 over k times k log base e of x minus 1 plus x to the power of k over kx. Now we can also write this thing as x to the power of k minus 1 over k, because I just brought this x up, so we can write this as that. So x to the power of k minus 1 over k. And now what we can do is we can take out this as a common factor because it's common in both of them. So x to the power of k minus 1 over k times k log base e of x minus 1 plus 1, and this would just become 0, so leaving us with this. Now we can cancel k and k out, leaving us with x to the power of k minus 1 times log base e of x. And that's what they wanted us to show, and we have done that, and now we can just say hence shown. So all the marks here goes for the correct method. So if I were to simplify that, maybe 1 mark for correctly differentiating this, and 1 mark to be able to show after simplifying that, you know, the differentiator of that is indeed equals to this. So what is the significance of this question? Well, I'll tell it to you when we are doing the next question. So calculate the probability that x is greater than 1 on e. So that is just like saying solve the integral of 1 on e to, what is our maximal domain? It is going to be 1, so 1 of minus 4x log base e of x, and we can also write this as minus 4 integral of 1 on e to 1 x log base e of x dx. Ooh, I forgot to write dx, that's 1 mark gone. Okay, do not forget to write dx, it's quite important. Now, how do I solve this integral? Well, now this will be done once you understand what we did here. Now what we basically proved here is that when we integrate x to the power of k minus 1 log base e of x dx, we will get x to the power of k over k squared times k log base e of x minus 1. Now if you were to see this, doesn't this and this look kind of similar, except we have to find the suitable value of k so that we can make both of this function equal to each other. So what would be the suitable k value? Correct, it's going to be k equals to 2. If I were to substitute k equals to 2 in here, we'll get 2 minus 1, so that would just become x times log of ex, which is what we have to integrate. So now it's going to be pretty easy, so we can just say that negative 4 1 on e to 1 x log e of x dx is just going to equals to negative 4 x to the power of 2, because we took k as 2 to get x log ex, so our k value is just going to be 2 over 2 squared, which is going to be 4, times 2 log base e of x minus 1, and of course we do not forget our terminals, so 1 on e and 1. Okay, now we can simplify this, so 4 and 4 cancel out, leaving us with negative of this whole thing, so x squared times 2 log ex minus 1. Of course, we do not forget the terminals again. So now we'll just substitute in our endpoints to get the answer. So minus 2 log base e of 1 minus 1 minus 1 on e squared minus 2 log base e of 1 on e. Now we can also write this as e to the power of minus 1. Now I'm just going to bring this, oh sorry, it's not going to be meant to be minus. Now I'm just going to bring this negative 1 at the front, log laws, to get our answer. So this would just simplify to negative 2. Now the reason being that we had this over here, so 2 log base e of 1 on e, right? This is same as writing 2 log base e to the power of minus 1. Now if I were to bring this one down, it would leave us with negative 2 log base e of e. Now it's a property of log that log having the same base is going to just equal to 1. So this is a property of log, so that's why this part over here is just going to be 1, leaving us with negative 2. So that's how I get negative 2 minus 1, and now we'll just have negative of negative 1 over here plus 3 on e squared after simplifying this bracket over here. So our answer is just going to be 1 minus 3 on e squared. And there you go, that's how you do this. Okay, hence explain whether the median of x is greater than or less than 1 on e, given that e is greater than 5 on 2. Now how do I do this? Well, it says hence, and whenever it says hence, we always look up. We always look at what we did in the question and how we can use it to get to the answer of this question. So what I'm going to do, I'm going to use the information that probability of x is greater than 1 on e is going to be equals to 1 minus 3 on e squared. Now the reason why I did that is because we are looking at 1 on e, specifically, question relating to 1 on e, and probability, and the one that we did before is literally the only question that we, that it relates to 1 on e, so I'm just going to use that question to do this. Now from this we can determine that 3 on e squared equals to 1 minus probability of x is greater than 1 on e. So that means that e squared is going to be equals to 3 on 1 minus probability of x is greater than 1 on e, right? Now, as given in the question, e is greater than 5 on 2, meaning e squared is going to be greater than 25 on 4, right? So that means that 3 on 1 minus probability of x is greater than 1 on e, that is going to be greater than 25 on 4. What I did here was I just used e squared as this over here, because e squared and this entire function are equal, so I just used that. So meaning now we can say that 1 minus probability of x is greater than 1 on e is going to be less than 12 on 25. So probability of x being greater than 1 on e is going to be greater than 13 on 25. Now how does this give any information about the median? Well, Since half is greater than probability of x greater than 1 on E, which is greater than 13 on 25, median is greater, sorry I spelled it wrong, greater than 1 on E. Now if you don't know what median is, I'll just use this graph to quickly explain what median is. So let's say that we are having a random x value on this graph, right? If that x value divides the graph into two segments, two parts, such that this part over here, this area under the graph is equal to 0.5 and this area under the graph is equal to 0.5, that value, so median in this case would be x. So that's how you find median of probability density function. Now if you want more information on that, I have a video on continuous probability, make sure to watch it. I'll attach the link in the description below. But other than that, our exam 1 of 2016 is already done. So I hope you learned from it, and I will see you in the next video. Bye bye.